Very good morning. In last class, we discussed about secondary distribution of overheads. So, in secondary distribution, we are going to redistribute the overheads of service department to the production department. So, in that, we have several methods. The first method is inter-service being considered. Another method is inter-service not considered. In inter-service being considered, the service of one department is utilized by another service department. If inter-service is considered, we have two methods. One is reciprocal method, one is non-reciprocal method. In reciprocal method, we have repeated distribution method, simultaneous equation method, and trial and error method. In non-reciprocal method, we have only one step method. In inter-service not considered, we have direct distribution method. So we have seen direct distribution method, we have seen step method, we have seen simultaneous equation method. In today's class, we are going to see repeated distribution method and trial and error method. So here we have a question. A manufacturing concern has 3 production department and 2 service department. In July 2008, the department expenses were as follows. Production department A, B and C 16,000, 13,000 and 14,000. And service department, you have two department X and Y. So the service department expenses are charged out on a percentage basis. So expenses of department E to department A 20%, department B 25%, department C 35% and department X 20%. And department expenses of department Y, department A 25%, department B 25%, department C 40% and department X it is 10%. Prepare a statement of secondary distribution under repeated distribution method. So to start with secondary distribution, of overheads, particulars, department A, department B, department C, department X, department Y. So let us start with the expenses of department X. So first let us take the expenses of the department, overheads of the department as per primary distribution. A it is 16,000, B 13,000, C 14,000, X 4,000 and Y 6,000. Now let's start with department X overheads. Overheads of department X. So department X overheads will be given in the ratio of 20 is to 25 is to 35 is to 20. Otherwise you can divide it by the fifth table. 4 is to 5 is to 7 is to 4. 20 is to 25 is to 35 is to 20. Otherwise we can have it like this. When you divide it by 5, it is all these are commonly divided by 5. It is possible to divide it by 5. So I am dividing it by 5 and making it as 4, 5, 7, 4. So taking this 4,000, we have to share it among the other department in the ratio of 4 is to 5 is to 7 is to 4. So we will be getting 800, 1000, 1400, 800. Next, second, overheads of department Y. So Y it is given here as 25 is to 25 is to 40 is to 10. So we can make it as 5 is to 5 is to 8 is to 2. So while taking Y, see Y has already got 6,000. Y has already got 6,000, and here there is 800. So totally it is 6,800. So this 6,800 should be shared among A, B, C and X in the ratio of 5 is to 5 is to 8 is to 2. So it will be 1,700, 1,700, 2,720, 680. After now, again we have got share for X. So again we have to go on continuing it till the values of X and Y become obsolete. Till it becomes obsolete, you have to go on continuing. That is why it is called as repeated distribution method. You are going to do it repeatedly till the overheads of service department gets null. So now next, third step, we are going to take overheads of department X. Overheads of department X 680. This will be shared in the ratio of 4 is to 5 is to 7 is to 4. So 136, 170, 238, 136. Now we have got for department Y. So again we have to share this 136 to other departments in the ratio of 5 is to 5 is to 8 is to 2. So 34, 34, 54, 14. Next, overheads of department X. Now this 14 has to be shared between other departments. So 4:6. This share will be Y will be getting 4. So again we are not going to do it calculate it, so we leave it blank, because when you again go for sharing the 4, it will be in decimals, it will be in decimals. So to avoid that, we will stop here itself. So we assume that it has been a nil value. If you are taking 4 and sharing it to the other departments, you will be getting it in decimal points. So to avoid it, we will stop it here. So now total overheads. So 800 plus 1700 plus 136 plus 34 plus 4. 18,674. 13,000, 1,700, 170, 34 plus 4. 15,908. And for C, it is 18,418. So this is called as repeated distribution method. Taking the overheads from the primary distribution table, the overheads of service department are distributed to the production department and also to the service department repeatedly till it becomes till the overheads of service department becomes obsolete. Next question. In a factory, there are two service departments, 1 and 2. And 3 production departments A, B, and C. In April 1992, the department expenses were A, B, C, 1 and 2. So these 3 are production department and these 2 are service department. So these are the overheads as per the primary distribution. So here you have to take this primary overheads as per the primary distribution and you have to allocate to the production department, also to the service departments, the same way as we did in the previous problem. This is also a repeated distribution method. So secondary distribution of overheads under repeated distribution overheads as per primary distribution method. So this is particulars. Department A, B, C, then 1, 2. So it is 6,50,000, 6 lakh, 5 lakhs, 1,20,000, then 1 lakh. So first one, department 1 expenses overheads. So it will be apportioned to other departments in the ratio of 30:40:15:15. So we can use the fifth table and we can simplify it. 6, 8, 3, 3. So this 1,20,000 has to be distributed among the other departments in the ratio of 6:8:3:3. So it will be 36,000, 48,000, 18,000, then 18,000. Next, department 2. The ratio is 40:30:25:5. 40:30:25:5. So we can make it as 8, 6, 5, 1. 1 lakh plus 18,000, so totally it is 1,18,000. This has to be shared in the ratio of 8:6:5:1. So we will be getting 47,200, 33,400, 29,500, 5,900. Third one, department 1's overhead. The ratio of 6:8:3:3. So we have to take this 5,900 and divide it among the other departments. So 1,770, 2,360, 885. Again it is 885. Next, department 2 overheads. So 885. The ratio of 8:6:5:1. 354, 266, 221, 44. Next we take department 1's overhead. This 44 to the other departments in the ratio of 6 is to 8 is to 3 is to 3. So 16, 20, 8. So if you are going to share it to the department 2, it is going to be 8. Then again, if you share it, you will be getting it in decimal value. To avoid that, we will stop here and we will put nil to the department 2. Now total overheads. So 6,50,000 plus 36,000 plus 47,200 plus 1,770 plus 354 plus 16. You will be getting 7,35,340. 6,86,046 and 5,48,614. So this is repeated distribution method. Next we are going to see trial and error method. So PH Limited is a manufacturing company having 3 production departments A, B and C and 2 service departments X and Y. The following is the total of overheads as per primary distribution A, B, C, X, Y. So A is 4,100, B 2,700, C 6,200, X 4,200 and Y 5,300. And this is the ratio of apportioning to the production department from service department. So instead of taking all the departments, we are going to take only the service departments. Instead of taking all the departments, we are going to take only the service departments. So for that we need only three columns. Particulars, service department alone we are going to take service department X, service department Y. So overheads as per primary distribution. Overheads as per primary distribution. Overheads as per primary distribution is 4,200 and 5,300. Now first we start with share of y in x over x. Share of y in x over x is 10%. So 420 goes to y. Next, share of x in y's over it. It is 5%. So 5% of 5300 plus 420. 5% of 5300 plus 420. So you will be getting 5720. 5300 plus 420, you will be getting 5750, and you have to find what is 5%. So you'll be getting 286. So 286 will move to x. Now share of y in x over it. So 10% goes to y. So 28.6. So 28.6 goes to y. Next, share of x in y's over it. Share of x in y's over it. So you have to find what is 5% of 28.6. So it is 1.43. So 1.43 goes to now share of y in x over x. You have to find what is 10% of 1.43. So it is 0.14. 0.14 goes to y. Now you have to add those things which are not in the bracket. So 4200 plus 286 plus 1.43 it comes to 4487.43. So we keep it as 4487. Like that here, 5300 plus 420 plus 28.6 plus 0.14. You will get 5748. 8.74. So we keep it as 5,749. Next we have to prepare secondary distribution table. So here we will be having a column for particulars, total, production department A, B and C. So overheads, as per primary distribution, $13,000, $4,100, $2,700 and $6,200. 4,100, 2,700, 6,200. So when you add these three things, you'll get 13,000. So now service department X overheads. So as we calculated, it is 4,487. We have already given the share of Y. So when you total these things, you get 100%. When you total all these four, you'll be getting 100%. We have already given the share of Y. So 100 minus 10, you'll be balance. You'll be having 90%. So that is 90%. So we have to find out what is 90%. So 90% of 4487 is 4038. 4038. Because we are not taking the share of Y. This has been reduced. That is why we are taking the balance 90%. 4038. So this 4038 should be shared in the ratio of 45:15:30. Otherwise 9:3:5 6. Like that, you have to take service department Y overhead. So 5,749 into, So when you add up all these things, you'll get 100 percentage. From the 100 percentage, this value we have already given. So we have to take the balance. So balance is 95 percentage into 95 percentage. So 95 percentage, you will be getting 5462. So this has to be shared in the ratio of 6G is to 35. That is 12 is to 7. It's only for department A and B. It is not for C. So department A, you'll get, first we'll complete the first one. It is 2019 673 1346. $3,450 2012. See, it's nothing. Total overheads $22,500, 9,569, 5385, 7,546. So this is called as trial and error method. So we have seen all the methods. First one is direct distribution method. When there is no inter-service, at that time you can go for a direct distribution method. When service department is not doing service to any other service department, we can use this direct distribution method. Then we have seen step method. When service department are doing service to restricted departments, then we can go for step method. If it is reciprocal, one service department is doing service to other department and that department is again doing service to the other department, we used to call it as reciprocal. Then at that time we can go for repeated distribution method or simultaneous equation method or trial and error method. So we shall break the class now. We shall meet for the next session after the break. In that we will discuss about how to calculate both primary and secondary distribution.